How's it going, everybody? Now, before I go into the video and the main point, I just want to say that I know that I haven't been making any videos recently, and that is because of some reasons that I don't really want to get into right now. But I am aware of that, but I'm back. I'm better than ever. I have a new tripod that I'm using to record this. I also have a new background, a table to record on. I know this background isn't exactly ideal, but it'll do for now until I get a new background, and I am working on getting better camera equipment, such as a microphone, a better background itself. But until then, I'm happy with what I got, and I'm sure you guys are too. So without further ado, let's get into the main point of the video. In this video, I'm going to be talking about what conjugates are and how they're helpful to make your own algorithms, and also I'm going to be teaching you how to make your own algorithms using conjugates. Now, most people use commutators to make algorithms, and I'm also going to be telling you why it's better to use conjugates instead of commutators, but really it's up to you. So let's start with talking about what are the differences between a commutator, which is what most people use to make algorithms, and the differences between a commutator and a conjugate. So let me just zoom in a little bit. Okay. Now, a commutator is when you do an algorithm or a move, the first one, then you do a second one, and then you undo algorithm 1, and then you undo algorithm 2. So this is the format of a commutator. You do algorithm 1, algorithm 2, undo algorithm 1, and undo algorithm 2. Probably the most classic commutator that we all use to solve is the RUR prime U prime. So the algorithm 1 is R, algorithm 2 is U, undo algorithm 1, undo algorithm 2. So an example of using that in a solve is if you want to get this cross, you would do F wide, this commutator, F wide prime. But we're not using commutators. We're using conjugates. So let's talk about the format of conjugates now. Now the format of a conjugate is you do a setup move or moves, then you do a main algorithm, and then you undo the setup move or moves. A classic example of a conjugate is also including the RUR prime U prime, which is the commutator that we just learned. So the way you can use the conjugate that I'm talking about is instead of just doing RUR prime U prime, you do the setup move, which is F, and then you do the main algorithm, which is RUR prime U prime, and you undo the setup move, F prime. Now let's go ahead and move this cube aside, and I'll show you how conjugates are helpful using an actual math problem. So let's go ahead and do the classic 1 plus 1 equals 2. Now before we go in further detail of what the point of this is, I'm going to explain what the setup moves are for in a conjugate. The setup moves in a conjugate are to change up what the algorithm is doing. So in the FRUR prime U prime F prime conjugate, the regular RUR prime U prime does this, but adding the F at the front, at the F prime at the back, at the end, I mean, you can get it to do this. So let's go back to our math problem. So let's say the 1 plus 1 is the actual algorithm. So what we're doing in the algorithm. So alg. And the 2 is the outcome of what you actually do in the algorithm. To show you what I mean by this, I'm going to be using a J-perm. So the 1 plus 1, or algorithm, is the actual what you're doing in the algorithm. And this kind of J shape that you get is the 2, or the outcome. So this is our whole algorithm. This whole thing is our whole algorithm. But let's say we don't want the outcome to be this 2, right? So we don't want it to be 2. Let's say we want it to be a 3. So we want this J-perm, or this 1 plus 1, to look just a little bit different, right? So we can't just do 1 plus 1 equals 3, because 1 plus 1 is 2, not 3. So we have to change the actual algorithm, because we can't just change the outcome, because if we do the algorithm, we get the normal outcome, not the 3. So in order to get what we want, we have to change what we do. So we have to turn this into a 2. So 2 plus 1 equals 3. And that's true, and that's right, isn't it? 2 plus 1 does actually equal 3. So this 3 is what we want, because it's the outcome. The 2 is the setup move, or moves, because the 2 is what we have changed. This 2 is including the undoing the setup moves, like we wrote up here. And this 1 is the main algorithm. So this whole thing, in conclusion, in order to get what we want, which is this 3, we have to change what we do, which is this 2 and the 1. Now let's go ahead and move this to the side and apply this same principle to the actual cube. And for this example, I'm going to be using the H-perm. For those of you who don't know what the H-perm is, the H-perm is where you have two opposite edges on the top layer that are switched. So it kind of makes an H, even though it really makes a cross. So the doing of the H-perm is this 1 plus 1, and the 2 is what we get. But let's say the 3, which is what we want, is not for these 4 edges to be switched, but we want these 2 edges and these 2 edges to be switched. So that would be our 3. So we have to do our setup move, and then the main algorithm, and then undo the setup move. So to change up the algorithm using setup moves, we can move these 2 edges into the place of where these 2 edges originally were, and we can do our H-perm, and then undo our setup moves. So now, as you can see, these 2 edges have been switched, and so have these 2 edges. So we just made an algorithm to get the 3, or what we want. So let's go ahead and write down the algorithm that we got. So our 3 is switching these 2 and these 2 edges. Now let's go ahead and start with the 2, or setup moves, which is an M2, and now our 1, or main algorithm, which is the H-perm, whoops, forgot the R, and now undo the setup moves. So back to 2, which is M2, and then we get the 3. So what we want. Now, let's go ahead and make one more algorithm before I go. But before that, I need to say one more thing before we make our new algorithm. The purpose of making your own algorithms for non-WCA puzzles, or just figuring out not a WCA puzzle, is to either get exactly what you want from point A to point B, or to turn what you don't know into what you do know. So what I mean by that is, let's say you don't know the H perm. You can use a conjugate to turn it into what you, let's say what you do know, which is, let's say, the U perm. This is the UA perm, I believe. So let me give you an example of that. So let's say you're solving a puzzle and you come across a Y perm. Now, you know all the algorithms, and you know you can change them up a little bit by using setup moves, but you don't know the actual algorithm for the Y perm. Now, like I said before, you can do one of two things. You can go from point A to point B, so go from this Y perm to a solved state, so from a 2 to a 3, because a 3 is what we want. Or you can turn it into an algorithm that you already know, which is what I'm about to teach you how to do. Alright, so here you are, you're in the middle of solving a 3x3, you don't know what a Y perm is. First thing you need to do, study it. So first thing I noticed that it's these two corners that are switched, and these two edges that are switched. And then I figure out what algorithm this is most similar to. So I noticed that this is more similar to a J perm, where you have two edges that are switched, and instead of these two corners being switched, you switch these corners. So in order to turn this into a J perm, you need to do a setup move. So this setup move can be, let's say, a B prime. Bear with me, guys, I use a different notation than most people, so yeah. And this B prime gets this corner over here. So now this basically is a J perm, because if we do the PLL, then it switches these two, and it'll switch these two. So let's go ahead and try that. So, alright, let's go ahead and write down our main alg. And now we need to undo our setup move, which is a normal back move. So just like that. And it didn't quite get us what we want, but it did turn it into something we know. If you guys know anything from corner twisting without actually corner twisting from the beginner's method, then it just turned this into an algorithm we already know. So for finish it off, we can go ahead and do twist corners. And what we want, or 3, is the solved state. As you can see, I did that from the wrong angle, so you have to be careful of that. But I just did that to show you what the algorithm would look like all sped up. So looking at our paper here, we have a lot of information. All this is how to make a conjugate, and we made 2 algorithms using all this information. I hope that this video helped. I know that first learning conjugates for me was kind of difficult, but once I got the hang of it, it became quite easy. I wouldn't say easy, but it just became less difficult. If this video wasn't good enough for you, then go ahead and check out Red KB's video on Cube Theory 101 conjugates. It's where I learned conjugates from, and it really did help me a lot. If conjugates don't help you at all, maybe take a look at his video on commutators, also Cube Theory 101. But yeah, we filled up a whole page on how to make conjugates. I hope this helped you guys. Peace out.